Hello, everyone. Welcome to Semantics conference webinar this afternoon. We will get started in just a few moments, so please sit tight. Thank you. I'm pleased to pass the mic to Moderator Conference Chair, Joe Hilger.
Thanks a lot, Madison. I want to start by welcoming everyone to the call. We're excited to have you here and excited to give you all a preview of the people and speakers and the different topics we're going to talk about at Semantics 2020. For those that don't know me, my name is Joe Hilger, and I am the COO and co-founder of Enterprise Knowledge, and I happen to be the conference chair of the Semantics Conference. So why don't I start by introducing some of our panelists. Kurt, do you want to go first? Kurt, you're on mute.
Thank you. My name is Kurt Cagle. I am a journalist, have written articles for Forbes, LinkedIn, a number of other places. I'm also the CTO for Semantic Data Group. I have to remember my own company. And have been writing in the space for quite some time. I look forward to the conference.
Wonderful. Alan, do you want to go next?
Yeah, thanks, Joe. Hi, everybody. Alan Morrison here with PwC, PricewaterhouseCoopers. I'm in my 20th year at PwC and always covering emerging tech. I'm part of a research staff that tracks 200 different enterprise technologies and their impact on business. And semantics and knowledge graphs are my hobby horse.
Love that. Lulit, why don't you go next?
Thanks, Joe. Hi, everyone. My name is Lulit Tesfaye. I manage the data and information management practice here at Enterprise Knowledge, leading design, development, and implementation of semantic technologies and AI projects. And looking forward to the first Semantics conference here in the US. I've been attending the one in Europe for many years, so excited that we're bringing it here.
Wonderful. Aaron, do you want to go next?
Thanks, Joe. Aaron Bradley. I'm a knowledge graph strategist working out for Electronic Arts, working out of Vancouver, British Columbia. As my title might suggest, some of my time is dedicated to educating users on knowledge graphs and evangelizing their capabilities, especially in regard to EA's own content knowledge graph. I work alongside ontologists and taxonomists in the creation of content models that are critical to powering that particular content graph.
And almost anyone on Twitter that follows knowledge graphs should know Aaron. Wonderful. Yanko, why don't you wrap it up and then we'll jump in.
Thanks, Joe. My name is Yanko Ivanov. I am the technology partner manager here at EK. My background is in knowledge management solution design and implementation with heavy focus on knowledge graphs and semantics. I've helped architect and implement solutions for various clients around knowledge graphs and semantic technologies.
Wonderful. And for those wondering, Alan's security configuration would not allow him to have video. So he's an equal among the rest of us, just not shown visually. For those that come to the conference, you'll meet him. So want to start by sharing some questions that we've preceded for this discussion. But really what we're looking for is, as you're thinking about semantics and questions that come to mind to you about what are the technologies, how does it work, what is it? This is about the technology side of semantics. In a few weeks, we're going to have a second one that's more about the business aspects, but we thought we'd start with all the technical questions. So feel free to submit some, and after we answer a few of these original ones, then we'll try to work yours in as well. Let's get started. So the first one, and Kurt, I'm going to address this to you. I think so many people know you. What would you say is the standard architecture of the semantic web? How would you describe that?
Well, in many ways, I think the architecture for the semantic web is really not that different from the architecture that you have for the regular web. The idea on the web, the thing that made it most powerful and made it expand so dramatically back in the early 1990s was this idea that basically nodes of information or nodes of servers could communicate to one another through a stateless protocol that allowed them to link via a uniform identifier. We call those URLs today. But essentially, any document, any web document that you have can be thought of as essentially a collection of links and metadata around that links with the scattering of text here and there. What happened in starting about 2000 was that Tim Berners-Lee, who was also responsible for the development of the architecture for the web, one of the people for the web, kind of came back to the same idea that he had been thinking about originally, which was, how do I connect information? How do I connect documents? How do I connect things? And once you start talking about connecting things, then the next logical step is to say, well, if everything out there had some kind of identifier, then that identifier could be used as a way of being able to address that thing and to be able to retrieve information about that thing. And so, you know, that thing could be a person, it could be a place, it could be an event, it could be a sensor. Really, it could be anything that you wanted to do, but essentially by having that identifier and by having a mechanism to be able to pull it in, to access it, then you could, utilizing that kind of architecture, could basically build out a web of content. And that's really where a lot of this has come from. So when you think about semantics, you know, you can think of it as, this is just the same thing as a bunch of links you have. It's just that those links are now much more machine readable. And they're basically designed to work in an independent fashion.
You know, Kurt, I love that. I always hear it's about things, not strings, and I think that's a great way of describing it. So Lulit, as I ask the question to you, you do a lot of implementations for clients, and you know, so your thought about this architecture might be, how does a client implement semantic solutions inside of their firewall? Any thoughts of what you would add, or how you would take Kurt's description more down that path?
Yeah, absolutely. So I would say, you know, to Kurt's point, it's really important to note that semantic technologies are actually serve as complementary to overall enterprise architecture, right? They are not necessarily a replacement. So typically, when we work on semantic projects, we look at it from the perspective of the enterprise in defining that overall, or supporting the overall information lifecycle or continuum. So defining the organization's ontology or vocabulary and the relationship that Kurt pointed out, mapping those relationships across both structured and unstructured data to be able to define what that enterprise architecture looks like and where semantics fits in across the organization. And I think it's also a few things to call out here that we see when we're going through implementation is that semantic technologies do integrate and consume information or provide information to other applications, right? So they leverage, as part of the architecture, APIs to, so to speak, plug into the architecture and interface with and provide the information and the relationship in context and meaning to different applications such as content management systems and search. And that standardized API is a big part of that architecture.
Wonderful. Moving on to the next question, unless someone feels strongly there's something we need to add to this. You know, we've got all these technologies involved in semantics, and among them, we're doing a lot of discussions about knowledge graphs, and then you have vendors producing graph databases, and you're hearing talk about the technology and the solution and what is it, and I think there's a lot of confusion in the marketplace around that. Aaron, do you want to kind of talk about kind of your description or depiction as to how knowledge graphs differ from a graph database? You're on mute.
Thanks. And with this, I will roll out my ever work in progress, as I think it is for all of us, definition of a knowledge graph, which I describe as a knowledge base of intelligently connected, machine-readable facts about things derived from one or more sources. So a knowledge graph is that collection of content where the relationships between the pieces have been described, and there are instances of the data that reside somewhere, which is the segue to a graph database. And that's where data used by a knowledge graph may be stored. And in particular, and especially in comparison to relational databases, which could also conceivably store that knowledge, but a graph database excels at representing relationship data. That is just not which things are present in a graph, but how, in a very formal sense, those things are connected to one another. So a graph database is a possible but not necessary condition for having a knowledge graph, but a knowledge graph is where that data is actually contained rather than the database or the holistic data rather than simply the storage of that data which resides in a graph database.
I love that. And of course, isn't it funny that the database type that's probably better at understanding or defining relationships is not the relational database.
Indeed, and that point is made by one fellow called Alan Morrison, where I cribbed a lot of that from. You'll find his answer on Quora if you search what is the difference between a graph database and a knowledge base. Very useful in this discussion.
Actually, so maybe what I should do is let Alan speak. Alan, why don't you pop in and share what you've written on Quora so that people don't have to actually go look in Quora, though they can.
And should.
Yes. Alan, you may be on mute as well.
Oh dear.
Let's see. While we're waiting for Alan, Yanko, do you want to add to that discussion? I know you've done a lot of this. Actually, you've had a few talks on this topic.
Yeah, absolutely. Thanks, Joe. I actually love the description Aaron gave. That's really a good way of thinking about knowledge graph versus graph database. In my mind, a knowledge graph is a solution. From a business perspective, from an organizational perspective, it's a solution. It's not just a tool, not just another database. A knowledge graph is composed of several different pieces, like we were just talking about in the previous question, the previous topic. Graph database being one of them. For example, graph databases, like Aaron said, it's the layer that we store the data, the relationships in triple format. But what actually provides the solution to me is the graph database, the knowledge graph rather itself. When we talk about knowledge graphs, there are multiple different pieces of it. We talk about ontologies, we talk about taxonomy, semantic augmentation of the content or the data that you are integrating as part of this knowledge graph. And when we talk about a graph database, that enables us to store these relationships that then can be consumed by various different applications. But the combination of the different components gives you the knowledge graph as a solution.
So, Joe, can you hear me now?
There you go.
I can. Do you want to add?
Oh, excellent. Miracles of technology. Just to add to this, I'm just going to tell a quick story about our recent micro conference, graph conference that we had inside of PwC, and it was at the tax leadership event. It was like a side event to that. And it was really illuminating for me to see how people were using graph databases. And you can imagine in our tax group, we've got these technologists who are really numerically oriented folks. And so they're using property graphs like Neo4j, for example, for ad hoc analytics primarily. So there's that use of the graph database, and then there's the semantic use of it. And I was one of the few people in the room who was familiar with the knowledge graph semantic approach to the use of graph databases. And so it was like a revelation to people that there was this approach to building extensible articulated knowledge bases. And so there's a lot of education that has to go on inside of business to really raise awareness about those capabilities.
Excellent. I like that. Good. Well, guess what? We've now got a bunch of questions, so I'm throwing our plan sheet out the door and starting to answer some of the questions people brought in. So the first one on the list, and actually I like this because it's one that I think will allow us to take this out of the technical depths and move it up a level. Someone said, aren't strings things? And so I think the answer is yes. Does anyone want to actually, Kurt, you've raised your hand. Would you like to help expand on that?
Yes, very much so. I think tying this back to what exactly a graph is, it's worthwhile thinking about a graph as essentially a way of, actually, let me step back a little bit. There's some, when we talk about graphs, what we're actually talking about are what are called network graphs. And these were basically pieces, these were technologies first discussed back in the 18th century by Leonhard Euler, mathematician. The E constant is named after him, and very, very famous mathematician. But one of the things that he did was to basically formalize the idea of saying, here are connections, networks that essentially encode information. Even going back, we talk about a network, but no one really understands or no one tends to appreciate the fact that when we talk about a network is basically consisting of nodes. In fact, net and node are fundamentally, based on the same originating terms. And similarly, the nodes are also connected into this particular network to be able to create nets. So when we talk about nets and nodes and edges, what we're doing is basically saying, here is a way of creating a representation of a concept with each node, tied together with these representations that are given with the edges or properties that bind these nodes together into something that you can catch fish with, hence networks. If you think about those nodes as simply being placeholders for concepts, then those concepts can really be anything. They can be strings of information, and that actually is used quite extensively when you start talking about natural language processing. They can be functions. They can be blocks of JSON. They can be really representations of anything out there, so long as you have some way of tying together an identifier to that node that says, when I'm talking about this particular identifier, that node can then essentially describe strings, it can describe numbers, it can describe entities by the connections that are made available to it. A string by itself could be considered to be one of those representations. I do this all the time. When you start talking about, here is a paragraph of information. That paragraph basically is a concept. That concept can have an identifier and can be referenced. And from that concept, you can then say, not only here is this particular paragraph, but here are the concepts that are contained within that paragraph. So,
point it out. Yeah.
I'm sorry.
Go ahead, Kurt. I'm sorry. Go ahead.
Realistically, when you're talking about these nodes, it's a framework for attaching things to a broader network of knowledge and information. And I think that's really one of the concepts that we need to kind of emphasize more and more, is that because these representations, the graphs themselves, are conceptual, it means that yes, we can talk about strings. We can even talk about programs, applications, processes. Anything you want can be attached to each of these little knots in the vast net of the information space.
I like that. So, before we head off, I'll tell you my aha moment was in search, and then it sounds like Aaron's got something to add here. When I've done search for years, and it was amazing to, instead of search for a term and think of it as just a piece of text, for me to know that that's a country or a person, et cetera, and the difference search would make when I knew what it was. Aaron, do you want to add to this?
Yeah. As usual, I give the simple perspective. I'm a simple fellow. Excellent description there, Kurt. In my simple mind, though, a string can be replicated many times, even though it has different meanings. I'll go to a famous go-to example. So apple and apple are the same string, but in one context, it refers to the technology company Apple, in the other to the delicious fruit that grows on trees. As a string, those you may be able to deduce the meaning of those through context, but a machine may or may not be able to do that, whereas that's normalized as a thing. To Kurt's point, that's essentially given a unique identifier, and that is what distinguishes a thing apple from that string apple, and allows for the process of disambiguation so that we can tell what the same string means in different contexts.
I'm sorry.
Yanko?
Go ahead. Just a quick note to add to what Aaron said. In my mind, it's just a good example. Obviously, Google. When you search for Leonardo da Vinci, Google knows exactly what and who you're looking for. It is a thing with an identifier, relationships, and additional information about this one unique person. And Google knows that this is a person. It's not just a string of letters that appear in a bunch of documents or websites. So to me, that is the difference between a string and an actual knowledge graph.
So we're getting tons of questions, which is wonderful. So I'm going to move off of this and on to another one. What are some ethical and/or social issues related to semantics and knowledge graphs? And do businesses think about this? This is a loaded question. Actually, Alan, do you want to start with this one?
Yeah, I think we can. At least I'll tee it up. And the way I think about it is that we have half the system is missing in many enterprises. When it comes to AI, you've got this statistical machine learning approach to everything, and what's been missing is the what used to be called the symbolic AI, and it's now represented in the knowledge graph. So if you have the knowledge graph with the statistical machine learning, you can have these contexts built, and you have a much higher fidelity amount of information to bring to bear on the challenges that artificial intelligence faces. So when you've got the knowledge graph in play, all of a sudden you can introduce a form of explainable AI. And I saw a demo a few weeks ago from a small company called Resolvian that focuses in the financial services area. And basically what they've done is they've built a decision support system. I mean, that's what they used to call them back in the day, that allows the explanations of how analysts arrive at certain conclusions. And so you could have a whole knowledge base, for example, and then just take answers to questions and insert them in your documentation. And so you can explain how you came to certain conclusions that way. You can imagine that machines could also harness that same knowledge base to sort of document why a machine might have arrived at a certain conclusion. Anyway, that's how I would try to tee up the ethical aspect of it, is that you have much richer information to harness to help with the ethical challenges.
I like that. Now I want to bring it kind of up a level from a business standpoint to some extent. Lulit, you've had clients that are rolling out knowledge graphs and building this AI, and how do you help them talk to their senior leadership to make sure that they're comfortable with this new kind of scary thing that's going to know everything you're doing and read all your content?
Yeah, thanks, Joe. So I would say I think it's always good to take a step back and start with deconstructing or breaking down the AI black box, so to speak. So when we start talking about machine learning or any of those advanced capabilities, the first question we ask is, what is your use case? What is the business case, right? Trying to understand in the context of what we're working with, especially in the context of information and data management, it's about making it efficient or optimizing data governance or data management, but also delivering information in a manner or context that we would like to process it or access it. So from that perspective, when it comes to making the business case for a knowledge graph or semantic solution or any type of advanced capabilities, we start with understanding the business case, and then we have a few questions relating to where we assess kind of that readiness to dabble in this space. But by that, what I mean is thinking through what kind of data do you have, how sensitive, what type of sensitive information you have. Going back to Alan's point, adding the context and the meaning is critical and the SMEs are critical in either introducing bias or validating the output. So that readiness process is a part of it. And just the overall using knowledge graphs and semantics as a foundation for that also allows us to give context from the perspective of the business and the business outcomes.
Wonderful. Kurt, something to add?
Yeah, taking up on what Lulit said, I think there's actually a number of key points there on ethics in particular. One of the things that's been mentioned repeatedly is the term context. And I think context is a wonderful term. It's a very complex term. Because what context basically does is it says this is the information not only that a thing holds about itself, but also about the universe in which that thing happens to be embedded. That context includes not only the immediate relationships, but also how other things perceive it, how information gets moves through processes, essentially providing what is called in the industry provenance. Where does information come from? Who has handled it? Why is it handled? This is a very difficult problem to be able to deal with in normal relational circles, or even in with most NoSQL databases, because they're basically dealing often with, here is a block of information that you may or may not necessarily have any idea where it came from. Once you start dealing with context and semantics, then one thing that does is it basically provides a trail that helps you to ascertain, is this authoritative? Is this something that has been approved? Has it been validated? Has it been cleansed? Is this information that is relevant, and what of this information should be utilized by various and sundry agents? Who has permission to be able to see what aspects of this? That's very, very contextual information, and it's information that's difficult to be able to handle any other way than in a graph, because so much of it's basically talking about externalities that affect the information at hand. So, I think that touches very strongly on the whole issue of ethics. We're dealing with ethics as how do we deal with ethics programmatically? How do we deal with ethics from the standpoint of how machines treat it? And I think that's a very key part of that.
Wonderful. And, it really does, I think some of that message is that these technologies, while they're scary at first, because they're smarter, they actually allow us to make safer decisions. And that's, when you're talking to an executive, is a really important message, that we understand what we're looking at. We understand all the content you have, because you have more content than you really can control. Sometimes ignorance is bliss. So fun one here, and this is probably for almost everyone. Tell us the most unique or innovative knowledge graph solution that you've bumped into, either through your time building stuff or working with different clients? And Aaron, I know you are tracking all of this, so I saw you thinking about this because you probably got 15 on your mind. What was the coolest thing you saw built coolest solution you saw built on a knowledge graph?
Not having been prepared for this and having such a stable, I'd probably have to revisit this, but
Okay.
a knowledge graph can be constructed for anything where there's relations where need to be exposed. I know that Pool Party collaborated, for example, recently on a Noam Chomsky knowledge graph, which makes a lot of sense. So yeah, I think so.
Excellent.
So that's an example that comes to mind.
And for those that don't know, can you share who Noam Chomsky is?
Noam Chomsky, a linguist and political activist and philosopher, and it's interesting too when you think of something like Noam Chomsky, and this actually starts to already demonstrate some of the capabilities and uniqueness of a graph. Is he a linguist or is he a political activist? And in the world of nodes and edges, you can be both, and you can be connected to all sorts of different groups of people and works that you've produced and conferences you've attended on both those streams. And they're quite different connections, but all related through the same person.
Wonderful. Lulit, I know you've built a few, so what's your favorite story here?
I actually want to bring it back to the Semantics conference last year in Germany. And if you remember, Joe, we used a knowledge graph. I think I met a lot of you there. We used a knowledge graph to guide. There was an app for the whole conference where you'll be able to connect. You just provide a little bit of information about yourself, and you'll be able to see what topics or which speakers are relevant to you, and also connect with individuals who are in the same space based on the similarity of interest and topics, and based on kind of your profile. So I thought that was a cool thing to highlight.
It's interesting. Almost every recommender engine you see these days is taking advantage of context to do it in a better way. We've gotten smarter because of that. Yanko, how about yourself? I know you've worked on a bunch of these things. What's your favorite?
We've done a few. The one that comes to mind that was pretty cool was actually leveraging NLP and making the business. When we're talking about structured data, and you have vast amounts of data, it's difficult for business users to go in and type in the SQL queries to get the information they need. So making a tool that allows them to say, who was my most profitable customer last year, and get that information based on search on vast amounts of data. That was pretty cool. We got that implemented. It was good to see, and then seeing the reactions of the actual business users, that was a pretty neat feeling to see.
Good. Alan, I bet PwC's done a few knowledge graphs in their day.
Yeah, and we've got a couple of knowledge graphs internally, including the semantic layer in our Denmark firm as part of the data factory, and we're doing a pilot here in the U.S. that's comparable to that. But I think the case study that really sings for me is the Montefiore health case, and you may have already heard me talk about it. But imagine this chain of hospitals in the Northeast, some of which are in the poorest parts of the country, and imagine that you've got this fellow who's built a knowledge graph on a shoestring with DARPA contracts and grants. His name is Parsa Mirhaji, and Parsa is a cardiologist who just had a fascination with databases and thought he could do a lot more with databases. So he latched onto the semantic web standards. And so you can imagine what he was able to do with a knowledge graph in a hospital environment. Basically, he and this team of maybe half a dozen people built this question answering system, and they integrated all sorts of heterogeneous data with the help of this knowledge graph. And you can imagine all the different kinds of formats and the different kinds of information that a hospital has access to, but it's all siloed. So he brings all this stuff together in the knowledge graph, and he's able to make the hospital make a business model change, because at the time, hospitals were trying to move from a fee-for-service model to a pay-for-performance model. And so they didn't do more with their data. They need to do more longitudinal studies, et cetera. And the EHRs, for example, the health records, basically designed for billing purposes, not for longitudinal studies of patient cohorts. So anyway, this is a really exciting system, and it just shows what you can do with the likes of a distributed graph database like AllegroGraph, for example, that help them out with an annotation engine, and as well as open standards like the W3C standards. So hope that wasn't too long-winded.
No, that's a great, very specific example. Isn't it incredible? You have all this healthcare information that's in separate siloed databases. When you can add context and put together a tool that ties it together and starts to relate it, how powerful that can be for a hospital. Let me take another question. Goodness, there's a lot. So someone said, I'm new to this field. Do the identifiers of things change dynamically as definitions change to provide a system of a sense of history and context? And I want to take this even a little further, because I think there's a lot to this. These knowledge graphs are reading all of the information, so much information from so many different sources, and trying to define what these things are. Is it a person? Is it a place? Is it a country? What are those attributes about these things, and how do they relate to each other? It sounds massive. So how do we deal with change as to this thing is different, et cetera, with the scale at which knowledge graphs operate? Yanko, I think you've dealt with some scale here. How does that happen? How do companies deal with that amount of change?
Yeah, change is by nature is challenging. So when we start, and I'm seeing some of the questions here. When you start with knowledge graphs, it's important to start small. It's important to have a good grasp of what's happening, on where you're going with this. Understanding that if you define an object and you provide the ID for that object, the idea here is to have that ID to persist, to be maintained. And then when you get additional information or different names for that object, you create new relationships. That original ID still remains, but adding new relationships, you provide this additional context, like we were talking a little bit earlier about. We provide context to that information so that whoever is looking at it, the person knows that, yes, originally this was the name, now we have this other name, or this information is coming from different sources. So the integration part of this, and like I was saying, starting small and growing, showing the business value early. And the business value, the idea there is, if you start small, if you start, let's say, with a small one department, it's easier to implement this solution and show how it works. And then it's easier also to get the buy-in from the rest of the organization, where you show the value, where you show how it works, and it's actually making things more efficient, or it's allowing the very basic case. It's allowing people to find information and discover more information that they didn't know existed across different silos. And then all of a sudden, the rest of the organization says, hey, I want that too. It's easier that way to scale, like we were saying, and just add more and add more. That's the beauty behind graph and semantic technologies, that changing or adding things is easier than, let's say, if you were doing this in a relational model.
Great. Aaron, you lived this. Oh, Kurt, something to add?
Yeah. One of the things I've actually been thinking a lot about the aspects of change in time in the graph space. When you're working with information, one of the challenges basically becomes, what do you do with older information? What do you do when you change content? When you're looking at the architecture that's associated with any given system, one of the things that you actually have to ask is, how are you effectively managing that state change And in essence, one of the things that kind of comes out of this is that you can effectively think of a graph as, just as with a relational database, you can think of a graph as essentially a snapshot of information in time. The challenge often comes down to, if you start thinking about these snapshots, then if you're basically trying to track at the individual level how information changes, you can do that. But then you have to basically deal with, well, what do I do with the old information? So in many respects, the notion of moving into a forward sheet of graphs, kind of like you have graphene, and graphene basically can be structured in layers. So you can almost think of it as we need to be thinking about this from a design standpoint of effectively saying, as you change content, you are also basically essentially dealing with time itself as yet another dimension, or another relationship that you can build into, in essentially saying, okay, here is a snapshot. That snapshot exists at a certain point in time. When I do a change, I am now essentially creating a new state configuration. I'm now building out a different graph from that. Now, because such changes are usually very incremental, those snapshots are things that you can take out and effectively, condense to a much smaller delta of content.
No, go ahead, Kurt.
Okay, so as you're building these systems, essentially you can build them out with the idea of thinking, kind
of anticipating change, right? Oh. Kurt, we've lost you. You know what? And let me pick this up, because we actually have another talk. One of the submitted talks was about integrating time into a knowledge graph and how to do it. So there's a full 45-minute talk about just that subject. Next up is how do knowledge graph and semantic technologies help with SEO? We talk a lot about the behind the firewall things, but we've found that these technologies really help with SEO. And I have to start with Aaron, because I know he wrote a whole topic on just this thing, and I think your old website was SEO based. So you want to share how this all fits together?
Indeed, and I spent over a decade as a search marketer prior to whatever this is called now. So especially in contemporary SEO, knowledge graphs help a lot insofar as they provide semantics behind meanings. That is just, and when I say in contemporary terms, I think as everyone that works in search knows, and I think every user of Google knows, with the advent of the Google Knowledge Graph in 2012, Google made a step away, and they actually frame it this way, which is why we keep using this phrase, things, not strings, right? So that Leonardo da Vinci could be identified as a historical person that had, is then connected to other Renaissance artists and works that he's done and all that stuff, rather than a string and with a bunch of documents. So that changes the entire index in Google from a number of linked document summaries, that's what you would get in the search results prior to 2012, to, again, to riff on my earlier definition, a number of facts about things. And in providing web pages, thinking of the web in terms of SEO or other data artifacts to Google, where the semantics have been defined these days, chiefly through annotating that data with schema.org, you're not then delivering to Google a bunch of text, you're delivering to Google definitions and relations of things in a very structured way. So whereas previously you would have some text that said, my blue widget is $9.99, now you're providing that same information to Google in a very structured and formal and machine readable format that it knows precisely what a blue widget is, what price means, what currency means, how one product might be related to another. You can have a relation that says blue widget is used to connect red widgets to your green widget. So you're providing meaning behind what was previously textual content. And in what Google tries to do is to provide users with answers now based on the things that are identified in their queries, and they try to return facts about things in the payload that at one time would have been called search results, but may just consist of facts.
I bet this is important at EA.
Yes, a little bit.
Not a small way. Absolutely.
and to anyone that gets traffic from Google or wants to have information exposed in search about things that are important in their environment. And it's also caused a pretty fundamental, and I think still under-recognized shift in SEO, where you're no longer, or Google's intention is not to provide only information to users about where they can go to find more information in the form of web documents, but to provide that information directly.
Yeah.
Right.
I think we got one last one to do, and this comes up all the time. What is the difference between an RDF and a property graph? Alan, if I remember, had you written something on this topic before? Is that right? Alan, I think we've got you on mute. Okay, while waiting for Alan, Lulit or Yanko, either of you, I know you two have dealt with this. Do you want to describe the difference?
Lulit, do you want to go?
Any takers?
Yeah.
Yanko, do you want to
Lulit,
go?
Do you want to do or?
Go ahead. Lulit.
Right. So in my mind, the main difference between RDF and property graph, with RDF, we are, well, one of the main differences is that RDF is based on W3C standards. We talk about OWL, we talk about Sparkle, and so on. Whereas with property graphs, many of the vendors have they provide their proprietary language for you to query the graph. That's one thing. Another thing is with RDF, you have a triple between two objects in the relationship, whereas when we talk about the property graph, one of the benefits for property graph is where we have additional information about this relationship between the two nodes or the two entities. RDF also can do this. It's just a little bit more convoluted there. To me, that's the main difference. Obviously, both of them fit slightly different use cases potentially, but that's, in my mind, this is the high level. Lulit?
Yeah, sorry, I was. Go ahead, Alan.
I'm sorry.
Alan.
Just to interject now that I figured out that I was on mute. In general, what the physical difference between the two, you've got subject verbs and objects in an RDF graph, and you've just got essentially objects on both sides of a property graph. And the edge in a property graph has an attribute, a property. It can have a property. So in some ways, it's a more articulated data model, just at that level of explanation than an RDF graph is. And what you're seeing over the years is people working with more and more sophisticated graph data models. You're seeing hypergraphs, for example, emerging. And some of the people who were frustrated with the simplicity of the RDF graph have gravitated to these hypergraphs so they could have nodes within nodes and properties talking about properties, or just so they can do more wide-ranging modeling. Now, those folks are really way up in the ether in terms of where practical business might be. You know, these people are very good at what they do, and they have an impact, but there's only a few of them. So I would say that let's try to keep it as simple as we can for the business that needs to take advantage of this. And so our RDF has all these standards associated with it that are really useful, and they've been proven out. So that's one thing that Property Graph has yet to really accomplish on the knowledge graph side.
I love that. That's a great distinction. Wonderful. So we have time for one more question. I'm going to pull one. It says, can you talk about the idea of enterprise knowledge graphs? What's different in terms of approach and adoption when the use case is internal information, not public? So we just talked about SEO and everything. Now let's bring it behind the firewall. Anyone want to jump on this one?
I can start.
Yeah, go ahead, Lulit. Your turn this time.
Lead on.
Yeah, so I think from the enterprise perspective, internal content perspective, the biggest benefit, I would say there are multi-benefit for knowledge graphs, but I do want to give like one simple example of a use case that we have implemented with the largest space engineering organization, right? Their internal problem is to be able to identify an individual who's worked on a project 50 years ago, an engineer on a specific platform, right? So this use case may seem easy, but there is a lot of semantic concepts behind it. So here, going back to the question regarding, this is big, how do we scale, how do you manage change? Starting small from the enterprise perspective, we started with helping to capture and identify the text or the context or the taxonomy of the organization, right? So starting there with a small group of people and mapping the relationships between people, projects, engineering topics, and location. These were the 4 things we started with, just with starting with those and identifying the relationship among these, within these concepts or entities, and then returning facts allowed us to build a simple internal site, which is now backed by graph-based search, right? The knowledge graph behind is powering this relationship. And when you search now for a specific project, you'll see the topic, the engineering topic related to this, all the projects that are related to that topic, and also other projects that that individual has worked on that are similar. So the concepts of an enterprise knowledge graphs that is embedded in this concept, in this use case, is the fact that for the enterprise, one of the major use cases is to be able to help find, for search, enterprise search, to be able to find people, to be able to find content, and to be able to organize and describe your content and identify the relationship between a specific piece of content to another piece of content. So based on either similarities or the topic, or location, those things that we were referring to define the relationships. And at a higher level for the enterprise, this also allows with a couple of things, empowering the organization to be able to have an effective governance or data governance and quality within place. The more you're discovering relationships, the more you're uncovering hidden facts, but also identifying duplicate information. So there's a big cleanup aspect to this. So for big data, deduplication and data quality becomes a big piece of this. And understanding a lot of organizations, I think over 80% from our experience of content we work with within the enterprise is unstructured. So what the knowledge graph or an enterprise knowledge graph allows us to do is leveraging RDF standards. It allows us to organize this content using taxonomy, metadata, data catalogs, and also define the relationship across the board.
You know, Lulit, I love that you brought up the data side of it. We've had a lot of customers that have called us and said, hey, I built this great data lake and I have all my data everywhere. I have no idea what it is or how it fits together. So understanding the context behind their data is I mean, a big deal. So for the person that asked about those internal, that's a between enterprise search and understanding your data and how it relates together, those are two really classic examples of how people are using knowledge graphs. But they're the stepping stones. There's more than that. So we are coming to the end of our time. We have 3 minutes left, and I want to be respectful of all the great people who have joined this call to listen and the panelists who have shared their wisdom with us. So for those on the screen, this will be published and posted on the Semantics Conference website, this entire recorded webinar. In addition, for those that have been here and those that are reading this, we do have a discount code for joining the Semantics Conference, right? All these people and more will be there. So if you look on the bottom right of the screen, discount-webinar-15-923-485-799 is available till February 8th if you want to sign up for the conference and learn more. And for those that want a more business-centric description around semantics, this one was technical. The next one, which is on, I believe, February 13th, is going to be much more focused on kind of business concepts and taking it from that side of the house. And we'll be doing that with a new group of panelists. Not that this group couldn't talk both sides of the coin, but we wanted to help you meet as many of the people that will be here as possible. So once again, thanks for joining. We'll be following up with an email. This will be posted on the main site. And we'd love to see you at Semantics in Austin in April. Thanks a lot. Bye, everyone.